Today I'm going to talk about how to build any AI app using Airbyte data pipelines. The reason for doing so is because to build an AI app in general, you usually have like a back end, a front end, you have something for the AI model itself, you have a database. So here at Airbyte, what we deal with is the source to the destination. So essentially what our product is it's connecting any source, whether it's unstructured, whether it's a form of tasks, a form of like documents, or any type of like layering of data, and we connect that to any destination. So here we have examples. Google Drive to Pinecone, for example, is a good one because Pinecone is a vector store, and most AI apps use vector stores in order to actually have the embeddings and that we can analyze and run AI analysis on. So this is sort of like the core of our product. So I'm going to demonstrate through an app that I made, which was related to Spotify's API. And that app was essentially just ingesting Spotify data, like Spotify songs in your library, and putting it in a vector store, Pinecone, and basically running AI analysis on that and trying to see like what songs should we recommend to you based on your music interest. So the way that Airbyte works is sort of like there's automated syncing. So there's data pipelines that are automated from source to destination. So you can schedule cron jobs, you can do it manually, which I'll show later as well. Or you can schedule for 24-hour increments, 12-hour increments, so something like that. So incremental syncs are basically when you have new data, it updates your data store, it updates your data pipeline. So the new data is transferred to the destination. And we have data consistency, which essentially means we transfer data in a very schematic format. So it's ran as a stream, right? So it's like a get request, post request, something like that. So it's going to be a request that goes in and actually goes to the destination. And scalability, the way that we handle scale is we have up to millions of records for each connection. And it depends on, obviously, the API's rate limits. So in this case, I'm going to demonstrate a Spotify example. And Spotify only handles like 50 songs per request. So that's Spotify itself's limit. But Airbyte has infrastructure to handle those rate limiting aspects. And then there's also maintenance. So we have logs to show you how your data is being transferred, whether there's like a break in the data, whether there's like, a failure and why the failure is happening. So I think you'll see more as I show you the actual demo. So I built an app for if you're having a bad day, like if you're having an off day and you want to listen to some good music to hype you up, right? And so basically the app that I made was called Mood Match, and it's basically just like matching your moods to like a song that you want to listen to. So I'll demonstrate that really quick to show what I'm talking about. So here we go here. And this is just like a Next.js app. So I can simply just like run like npm run dev, which is just to run any Next.js app, right? And then I can show you here what's happening on localhost. So essentially this is the app. And it's very simple right now. It's just to demonstrate a very simple concept to you. So if you are having a sad day and you want to be happy and you type in the keyword happy, right? You find these matches. You get essentially a list of songs that are catered to you based on your music library. So in this case, it's based on my music library, which is here, which are my liked songs that I've stored in my Spotify, right? So these are the songs that I generally listen to. And it's basically building on top of that. And it's giving you the genres and all of that. So this is a very simple RAG example. This doesn't have to be like obviously what you build. You can build anything based on this, whatever. But the point of this, demonstrating this to you is that essentially like Airbyte is handling all the data infrastructure in the backend. So if you see here, this vector store that we have is getting populated with these embeddings. And these embeddings are basically vectorized values of that data points, right, from your Spotify library. So if you go to this library, that's being transferred to here. So now I'll show you how this is being done in Airbyte's actual platform, right? So this is our product. And if you go to connections, you can build a connection from any source to any destination. And so what I did is I went ahead and went to Spotify, like I built a Spotify to Pinecone connection, and I already had a custom connector. So the way that it works is we have like connectors that are already built in for us. So we have like Asana, for example, Google Drive, right? But if you want to build your own REST API connector, you can do so. So you go to Builder, and suppose I want to build like a Simpsons API connector, right? Or like a weather API connector, or something finance, like Polygon, or any API that I want, I can build a custom connector for it here. And I literally just have to go through here and add like a request structure. You can also do it through AI Assist, which is you can paste any REST API URL and it can actually scrape that and populate the request for you. So you don't have to manually do the request. And when I say manually do the request, I mean like have the base URL, have the right method, right? The HTTP method that you're doing. So I'm just gonna show you the thing that I did for Spotify because I already built that. So Spotify, this is how I set it up in Airbyte itself. And the beauty of Airbyte is basically like you put in your base URL, your token refresh endpoint that you get from Spotify itself, right? The API. And then you essentially generate a refresh token that you can generate from like a script that you make. And you have a client ID, client secret, which is derived from the Spotify API itself, if you've ever dealt with it. And you can just build a stream that navigates your data. So in this case, I'm tracking my tracks, like my items, my liked songs. But in your case, if you want to track audio features, for example, or something else, you can track those things and just have a simple GET request and have a record selector which filters based on the field path. And you can have parameters, like for example, here I have the limit to 50, but you don't have to, this is all optional. And obviously we have pagination, incremental syncs for new data, and parameterized requests, and all that good stuff. Oh yeah, sure. Sorry about that. All right, so now I can go to connections and actually show you how it's working under the hood. So Spotify is going to Pinecone, and essentially this is a very simple setup from that custom connector to Pinecone. And all you need is your Pinecone store, like your Pinecone store name, and like your Pinecone API key, and like your Pinecone environment, and all that good stuff, right? As you would make a normal Pinecone app in general. And then you would just simply run a connection from Airbyte source, Spotify, to Pinecone. So that's how it would be done under the hood. And now I can show you like the architecture of how I made this, but how you can make any app that you want to based on like this architecture. So yeah, this is the Airbyte part that I just showed you right now, like in the left side of the screen, right? And the right side is just the implementation, which you can do simply through any source and connector. So for example, I once did like an Asana app to Milvus, like the vector database. So you can have Asana as the source, and you can have Milvus as a vector database. But the idea is you essentially enter a keyword, that keyword is converted to an embedding, then it queries Pinecone, the vector database, then it goes back to your library, and then it gives the GPT-4 context, and that context generates a response back to the user. So that's the basic structure of that flow. And yeah, that is all. And if you want to add songs to the library that I'm pulling this app from, you are welcome to do so. And yeah. Yeah, so there's ways to do that. In this example, I'm not, because this is a very basic example. But the way that you would do that is you can go here and generate another stream. Right now, I only have a song stream, but you can generate like an audio features stream that comes from the Spotify API, and that shows you metrics like danceability, valence, like just scores that demonstrate like how happy or how sad or how like moody the song is. So that's kind of how you would do it like implementation-wise, but this is a very basic implementation, yeah. But yeah, if anybody has any questions about Airbyte itself, I'll be happy to answer. Yes. No, this is just basic generic text embedding OO2 ChatGPT, like just, sorry, OpenAI, yeah. I'm sorry, what? Mm-hmm. I think it's just using basic similarity and semantic search, but I don't know, like, so I don't think I understand your question entirely. Yeah. I think it's just that. Yeah. Yeah. Does anyone have any questions about Airbyte itself? Yeah. Yeah, sure. No. So I had to do it myself because we don't right now. Whenever you create a new connection itself, we only have a set number of sources that we support here that are already like inbuilt, so you wouldn't have to do anything. So for example, if I go to Google Drive or something, Google Ads, I would just like straight up go here and add it. Or I think if you go to Marketplace, these are the ones that are contributed to us. So I can go to like Asana and I can go here, but then I had to create it my own, which is why I went to custom. And these are the ones that I created on my own in Builder. The reason for that is because these APIs are like, I guess like different REST APIs that we don't have infrastructure for already. So then you would just create it. So that's why there's like Stripe, for example, created a custom Stripe API to have like products or something. So it can be for applicable to any like REST API, yeah, that we have. Yes. Yes. So this is all open source. So the marketplace is basically just connectors that people have given to us, contributed, and then we've like added, or if we've supported some of them as well, like our teams have. Yes. Yes. I'm not sure about the monetization. I don't think so because this is just like the open source community contribution. So I don't think that would. Yeah, I'm not sure about that. So we only support some of those connectors that are contributed to us. It depends on like what has been. So for example, like Asana, like we wouldn't actually go in and like have our engineering resources contribute to that. But it depends on like the use case and like what we're being given. So if it's an actual customer of ours, or is it just like an open source connector? Yeah, it's going to continue working for you. Yeah, all you have to do, there might be like a few maintenance bugs here and there and stuff. So like we have a Slack for our community developers, OSS developers that we support as well. So we can help you with those things, but we don't actually support the connector itself if you've contributed it, if that makes sense, like the entirety of it. Um, Usually, like, so for example, recently we had that with like Asana. Like, I did a project with Asana where we had that thing, and usually, like, we don't have like a specific error on our end that will rate limit, but like if you check the logs, it'll like usually tell you like, okay, you've hit the limit. So we do have like monitoring and logs for that. So for example, if I go to like a connection, like any connection here, like here, so I can literally just look at the logs that like whenever I'm running this sync from Asana to Milvis, and then I'll be able to track that and see like where the rate limit is happening. So I think we leave it up to the devs. I don't think we actually have like infrastructure for each and every single like connector. That was just like presumed in this case because Spotify's limit is like so small. So yeah. Yeah. No, I don't think so because that would be on the API side itself. Does Airbyte spin up another? Mhm. Oh, I don't think so. I don't think we have support for that. Yes. Yeah, sure, sure. So we have there's some other examples as well. Um, so like recently, what we did is like I guess do you want a Google Drive specific example or? Yeah. Yeah, I mean, even in that case, though, we wouldn't like obviously like download those documents. We would just like ingest those through the connector itself, and then like we're not actually storing anything in the connection itself. We're literally just like sending it from point A to point B. So like if we go to like Google Drive, for example, or if we just build like a connection with Google Drive, uh, or Google Sheets, for example, we can do. Like we would essentially just like ingest from your like you'd give it a spreadsheet URL, and we would take that and we would send it to like Databricks or S3 or some destination. So like that whole process would be the exact same. The only difference would be like you would probably have to define it differently. So like for example, you wouldn't need like all the parameterized requests and stuff like that. You would just need like straight up the HTTP request. That's it. So it would be a simpler version of like I guess a source to destination connection. I can show you separately as well after this. Yeah. I'm sorry, what? Yes, from Google Sheets. So the vector database is yours, right? So you would define that cluster or that instance or whatever, and we would essentially just like sync the data to that, but nothing is being stored. It's just being delivered. So it's just being synced to that. So like it's incremental sync. It can happen every 24 hours or something like that, but it's not being stored anywhere. It's just being sent. So it's being retrieved and sent. So nothing is being like per se like stored.
I think you would deploy your own, like with the database. It's on your site.
Yeah, it's not on our cloud, if that's your question. Yeah, I'm sorry about that. Yeah. Yeah.
How do you compare to like Zapier?
I think the way that, yeah, I think a lot of people have asked this question, but I think I might not be the best person to answer this question, but I think that our biggest use case is probably just like we have a lot of people like contributing like connectors to us, and us being able to like have like, for example, now we're coming up with like data transformation stuff for AI. So I think we're adding more things like that into our like data pipelines. And I think for us, it's more like if you want, like the devs could have more input into their connections. For example, I can add like pagination and stuff like that versus it being strictly a node code tool. So it's not strictly a no code tool, right? Like if I want to, I can make it a more developer friendly tool by adding all these fancy things with it. So I think that that's our like value prop right now. But in terms of Zapier, I'm not sure exactly how their product works, but I'm assuming it's like a little more towards that like enterprise side of things.
But you solve the same problem, basically.
Um,
Trying to figure out like, are you addressing the same problem? Is it more than that?
I don't think it's the exact same.
From what I understand of you guys, it's
Yeah.
you guys are more about moving data and information between platforms as opposed to triggering actions on another platform. Like Zapier is more when this happens, I want this to happen, versus you guys are more about data moving between different platforms. Is that fair to say?
Yeah, exactly. I think we're only handling the ETL part of things. We're not handling like the action part of things on the destination end. It's more like the in between the source and destination. Yeah. Yeah, I think, yeah. If you want to store files in Chroma, is there any way to connect a source from Airbyte to your own Chroma? Yeah. I mean, I'm pretty sure, yeah. Yeah, I mean, we can also, just like how we defined a source, you can also define your own destination as well. So you would just like have to make your own destination in that case, like your custom destination. Yeah, for Chroma, but I'm pretty sure in theory you could do it. Yeah. Right, yeah, I think we're good. All right, yeah, that's it. All right.
Thanks, Yvonne.
Yes.
Awesome. How's everybody's bingo card going? Have you guys crossed out any, or did everybody forget about this? All right. Cool. All right. If you get bingo, just shout it out and interrupt me, and then we'll all cheer. Okay? All right. Cool. Okay. So for anyone I haven't met, my name's John. I do DevRel at Arize. So if you are not familiar with Arize, we are an observability platform for different AI systems, whether it's ML, CV, or LLM generative systems. And I'm going to talk to you guys a little bit about evaluating agents. Keep the mood match use case in mind, the song use case that we just looked at, because we're also going to show a demo of how we could actually evaluate that particular system as well. So we'll go through each of those pieces. Folks have probably seen some of the stories on this slide. This is a little bit of background on Arize and who we are. But basically, has anyone actually seen any of these stories? Did any of these look familiar? Okay, so anyone who missed them, these are a bunch of examples of cases where agents have gone really wrong in public settings in the real world here. You have cases where a Chevy agent sold a Tahoe for $1. Someone was able to like jailbreak the agent to say it was a legally binding agreement. You have cases where a Google chatbot recommended that someone adds glue to a pizza so to add stickiness to the cheese. So you have these cases where LLM systems and agents can go wrong with different cases. And a lot of this is what Arize is around to avoid. So we are around to help make sure that any AI systems you build will function well and are not going to fall prey to some of either these really acute errors or problems, as well as just poor performance and bad responses that are a little bit more mundane. I won't go through too much of this. I think we get used by a lot of different brands around the world. We're a platform for tracing, evaluation, testing, experimentation, all throughout production and development as well, covering all kinds of different AI use cases. The tool I'm going to show you guys today and we're going to use for the demo is called Phoenix. It's an open source library that we maintain. It is a LLM tracing observability platform. So it's something that you can run locally on your own machine. You can access it on our site, totally free to use and totally open source. And so I'm going to go a little bit into detail on how we approach evaluating an agent, and then we'll show you guys some of that demo of it in practice. Before I like deep dive into that, who's built an agent in the room? Okay, like a little more than half. Has anyone tried to evaluate the agent or like add evaluation to the agent? Cool. How did, just like 10 seconds, how did you guys approach it, if you don't mind sharing? Anyone have an idea?
The biggest problem is browser automation. So I can evaluate the task that could be, where I can have some ground rules. For example, if there is a data extraction, I can create like data set to avoid this thing. But when it comes to environments like browsers, I don't know. I'm still there. I'm still stuck there.
Yeah. Cool. We should talk about browsers afterwards. I don't have it in here, but we've got some cool stuff we're playing with there. You guys, anything to add there? Print statements. There we go. That's always how it goes. It's like you start with the logs and the print statements. So hopefully this will be useful for giving you guys a framework to approach that, and I'll show you some tools too. So a little bit of background on what makes up an agent. I think a lot of people in the room are familiar, but it's helpful to kind of start with this sort of baseline so that we can talk about how to evaluate it. Our way of conceptualizing an agent is a system that's made up of these three different pieces here. It's made up of a router, skills and functions, and then some sort of memory. The router itself is the piece that decides where the agent goes and what kind of thing it calls. So if it gets some sort of user input, it decides what is the step I'm going to take from there. It can be an LLM with function calling. It can be an NLP-based classifier. It could just be code-based. It could be a bunch of different kind of structures of the router. And in some cases, in some agents, that logic is more distributed throughout the agent as opposed to one area where it's deciding where to go. And then you'll have different skills or branches, which are the things the agent can do. So this is where you get into, maybe you have a RAG skill, like we're going to look at in this example. You might have a skill that is engaging with a browser, for example. You might have an API call, anything like that that your agent can actually do. Every agent's going to have one of these because if it doesn't have some sort of skill, then it does nothing, and it has no capabilities in the real world. And then memory is kind of the piece that is storing information as your agent's executing. Oftentimes we see people storing a list of messages that correspond to what the agent has done. Again, depends on what your agent actually looks like and what it does, but this is kind of a common pattern that we see people storing a log of what's happened so far. Well, I'll talk really briefly about this because we're going to talk a little bit about RAG in the use case, but if anyone's unfamiliar with Agentic RAG, it's a concept of RAG systems where you add some kind of agentic capabilities. Usually that looks like being able to choose from different databases depending on the user's query, choose from different sources that your agent will pull from, or reflecting on the results of a query after it's run it and pulled it to see if it could actually improve those results by modifying the query. A few other kind of pieces that come into play there. Kind of skip through that for now. In terms of how we evaluate each of the different pieces, there's a few different kind of concepts that we use and techniques that we end up using. One is your typical kind of code-based evals. One is more LLM as a judge. And then one is just using human annotations or labeling in some way. So with the code-based evals, this is sort of your typical software unit tests or integration tests or something like that. So those do still apply in cases with an agent, and that's usually a place that you should start. If you can define an evaluation of some kind in code, it's going to be scalable and more deterministic in its result. So that's always a useful one to apply. They tend to be pretty simple though. So it's things like checking if the output matches a regex. It's things like checking for mentions of competitors in the responses from your chatbot. So they're more like spot checks or small things that you could test there. If you instead use an LLM as a judge approach, you can go a little bit wider with the types of things that you're evaluating. Who's implemented LLM as a judge? Nice. Love it. Okay, that's awesome. Yep. So I won't talk through it in detail, but the concept generally is you're taking some part of a run of your application, constructing a new prompt based on that, and going and asking a separate LLM for some sort of usually classification label that can rate that response in some way. And then the final piece is using human annotations. You can use human annotations for a lot of different things. They're typically expensive to come by or time consuming to come by, so they're usually a way to augment your system. They're not a sort of scalable way to run evaluation. That being said, you can do things like add the sort of thumbs up, thumbs down to your system that users can respond with. They can rate different responses from your agent or from whatever system you might have. You typically get pretty biased information through that kind of thing because humans are not going to rate everything. They're going to rate the really bad stuff or the really good stuff. So it's useful to get that feedback, but it's also, again, not like a formulaic basis for all of your evaluation. And so with some of those techniques, there's a bunch of different things you could use those techniques to evaluate within different systems. These are some of the more common ones we see for different kinds of systems. It's a mix of LLM as a judge techniques for things like relevance or Q&A correctness or hallucination, or it's more code-based if you're doing, like we mentioned, some of the, say you're generating code. A very easy code-based evaluator is to actually try to run the code in a closed environment and see if it runs without exception. Is the code runnable? Is a very easy kind of code-based evaluator you could use for that sort of system. And for all your skills, you can do comparison against ground truth data. That is an easy one that you can always do as well. If you have some sort of golden data set, or if you have a data set that you can use as a basis, that can form a way to benchmark your system as well, depending on the use case you're going for. All right. Any questions on any of that? I went through that pretty quick, and that covers a lot of stuff, but I want to show you guys some of the demo. Any questions before I hop over into that, though? Yeah. Oh, yeah, that's a fun one. So in addition to kind of the, when you have an agent, you have the thing, you can evaluate the skills and the things it can do. You can evaluate the router, do like function calling evals is a common one that we see. There's also a concept though of, is the agent taking the right path through all of its different capabilities? And so convergence is a type of evaluation that we do to basically measure the number of steps the agent is taking for a given query, and then compare that against the minimum number of steps it's taken for similar queries like that. So it's not really something that we run on like production data. It's more like an experiment you can run where you take, say, a question like, say you had a customer service chatbot and you gave it a question about like, connect me to a support agent. You come up with 50 different wordings of that or more, or a bunch of different wordings of that same question. Your agent should take the same path through its execution. And then you basically measure how many steps it takes to get to the end for each of those different runs. And you can kind of compare them against each other to see how much, like what % of the time is your agent taking the most optimal path for that type of query. The idea is it's converging on the most optimal path is the way we think about it. Evaluating paths that your agent takes is like a whole area that we're still trying to figure out, frankly. And so that's like one way we do it. the best way is really like just looking at traces of your data and doing like a little bit of a vibe check on what it's actually doing. You should always start with that, and then you can do things like this convergence evaluation to try to scale that up. But we've experimented with like an LLM as a judge for measuring the path and things like that. It doesn't really work super well. So this is our numeric representation of it, but it's something we're still exploring as well. Cool. Other questions before I keep going? All right, cool. So I mentioned keep the mood match use case in your mind. I'm going to show you guys our, whoa, that was weird. I'm going to show you guys our open source tool here, Phoenix, and talk through a little bit of some evaluations we've added to that particular application. So in this case, it looks a little bit funky because there's some extra kind of tracing that gets done here with Next.js apps. So it's something that we've actually gets automatically captured. But basically, this is connected through to, this is just running on my local host. It's kind of hard to see, but it's just connected through to that mood match app. And then each row here is one call to that, to the main kind of search route kind of path that that application has. And if I click into that, I can actually see all the steps that the agent will go through to try to retrieve a response. So in this case, we've grouped a case where the users inputted majestic as the word that they're feeling. And I can see the eventual responses that come back in here and some of the recommendations that get pulled for that. And then within that, I get this hierarchical view of the different steps that are taken to achieve that. So I can see the text that's getting embedded and the actual embedding that happens here. And so I can see, in this case, some of the information that's being passed through there. Then there's a step of analyzing some of the different songs. And so there's actually an LLM call that gets made in here to say, hey, the user's feeling majestic. Let's analyze some of the criteria that make up a majestic song, for example. And so this will actually go through, and there's an LLM call that's getting made here to analyze that, kind of the criteria behind that. And then there's a final LLM call to actually pull through the relevant songs based on the user's input there. And so I can actually see the final response back of the songs that are coming through. So this, again, it's a kind of a simple use case that we've gone through, but you can see that you're capturing information like the calls that get made to different LLMs, retriever steps that happen. In a more agentic system, you might also have tool calls that get made as well, too, that you can kind of see and capture tracing on to understand what's happening with each run of the application. And so I could just like spot check this and look through the data and start to read the traces. And it's always good to start with that, but obviously that's not a very scalable way to actually kind of view your data. And so I've added these two evaluations that you see at the top here. One of those is about the output format that's being used. And so one piece of this, if you look, is that one of the things that's being asked here by this model or by this prompt is to format the recommendations as song, title, artist, genre. So if I want all my responses to be in that format, one thing I can easily do is I can add an evaluator that will automatically run through my data and mark any cases where that's not the case. So in this case, if I click on this feedback tab, I'll see there's a correct label that's been attached for the output format here. The output does actually follow the correct format, so that's all good there. But if you look in this case, the output format actually has one case where it's incorrect. So I'm going to add a filter in here to filter for one of my evaluation labels. I should have copy and paste this because I can't type one-handed very well. I'm going to put this down for a sec. And so I can see the actual case where that particular evaluation failed. And if I go down and I look at the result, we do actually see that while it does get this kind of format here correct, it does add some extra pieces to it as well. So if I look at the feedback, it'll call that out. It'll say it doesn't actually match the particular format. So in this case, I can add these kind of minute evaluations to something if I want to kind of really zone in on one part of the agent or the system executing. Yeah, you have a question?
You defined the format that you would like to be outputted. Where did you define the evaluation?
Yeah.
Is it like a prompt?
So in this case, yes, it's a prompt. I'm using an LLM as a judge. So I'll pull up, I don't know why I got two. There's a file I'll share afterwards, but there's basically like an evaluate agent file that might be kind of hard to see from here. But essentially what's happening to do that is I'm pulling out relevant, so I track all these runs of my application, and then I'll pull out spans or traces. So I'll pull out those logs, and then I can run whatever kind of evaluation on the logs I want, upload it back into the platform. In this case, I've actually set up two. One is this evaluate output format, where I'm using an LLM as a judge with that prompt you see right there to actually judge the format that comes out. And then there's one more eval that I've run as well, which is more of a evaluating the recommendations and having it categorize the recommendation that's made on a 1 to 5 scale, again, using an LLM as a judge to actually do some of that categorization. And so if I pull this up in the project here, you'll see there's actually like a song relevance score that's being captured there, where it's rating the relevance of the songs that are retrieved from 1 to 5. So in this case, I can see the 4s and the 5s that are being done. And say I wanted to go back to my, oh, I lost my filter. All right, sorry. I am going to retype that, so give me 10 seconds. So say I saw that this one made a mistake here. I wanted to actually try to improve that. One thing I can do directly in the platform is I can hit this playground button, and that will grab everything from the call that's being made there for the LLM call. It'll populate it into the system. It would actually grab in tool calls and previous messages and all kinds of things as well, output schemas that are being attached. It would pull all of that in, and I could make whatever prompt updates I wanted to in here. So I could actually modify my prompt, and I could rerun it across that data. So I could actually say, like I could add whatever I wanted to into here and rerun that through the application, get a new response, see if it actually improves. And I could actually even go one step further too and say, hey, this case, it actually seems like it improved that second time. I could actually test out my new prompt over a set of different examples from a data set to make sure that that change doesn't break something in some other part of my application or in some other kind of test case. So I've gone decently quick through that, but wanted to show you guys a few pieces of platform. There's a bunch more that I'm not touching on, from experiments that you can run that are more kind of closed cases where you're testing for very specific criteria or attaching evaluations to CI/CD runs or things like that. So as you make changes to your application, those will trigger off as well. But I want to keep it to just that because I know I'll lose people if I go too much further. Come back to that in a sec. Any other questions on anything I just went through there? Yeah.
Do you have any dashboards, like when you do evaluation by an LLM, your prompt itself may have different judges, if you will, different LLM, different prompt? Do you have a dashboard that can kind of show how everything going with all these different permutations?
Yeah, it's a good question. So we don't necessarily have a dashboard that will automatically capture your judge runs for you. However, what you can basically do is I kind of flashed this up on the screen. We have this concept of experiments where you can have a data set of ground truth, run that through something like an LLM judge, for example. You could basically test a bunch of different models. And in this case, you can end up with a kind of row of your different experiment runs with the evaluations attached to them of the kind of alignment or the success rate or whatever other kind of criteria you want to have. So I could basically create a system where I have GPT-4o, GPT-4o Mini, Claude 3.5 Sonnet, all those ones, tested against some existing kind of runs of my application to see whether the label that those models attach matches a human ground truth label and kind of what the success rate is there. So it's something that you can do within the open source platform. I will say we have an enterprise platform as well too, which has a lot of kind of custom dashboarding and some other features like a Copilot built into it. Within that, you do get a dashboard where you can kind of set that up and you can see the LLM judge alignment rate to specific kinds of tasks that you're having it run or specific models. So open source is a little bit more like DIY. You have to set that up yourself. Enterprise, you have that out of the gate. Yeah.
Might be a dumb question.
Never a dumb question.
Is there a way to programmatically use the evaluation to improve the system itself?
That is a great question. Not a dumb question at all. So not built into the platform yet. So basically it's like, can you optimize your prompts or can you optimize your tool descriptions or whatever it might be based on the evaluation results that you see and have that kind of like automatically create a loop there? You'd have to code it up now, but like you could use the pieces of the system to do that. It is an area that we're thinking a lot about, and there might be something more there in the next few months. It would not technically be RLHF because if you're using the LLM judge results, that's like RL based on, I mean, it's like prompt optimization based on the LLM judge responses. So it's sort of a similar kind of thing. You could also, I didn't really show this, but you can do human labeling within the platform as well too. So I could show you like, I could add annotations and things like that in here. And so say I hooked it up in that way, I was showing up the thumbs up, thumbs down. You could feed that back in the same way. That would be closer to RLHF at that point. But again, you're tuning the prompts as opposed to like tuning the actual model. So it'd be slightly different, but yeah. Yeah.
Let's walk me through how would the integration look like. Let's say I have a project in production, some kind of agent based on LangGraph, LangChain. Currently, I use Langsmith. So what would I need to do to switch from Langsmith to Arize?
Yeah, great question. So basically what you need to do is instrument your application to be able to send this trace information to Arize or to Phoenix. We're built on top of OpenTelemetry, if that's familiar to anybody. It's like an underlying standard. So if you've already implemented OpenTelemetry, which Langsmith isn't built on OpenTelemetry, some other observability platforms are. Good news, though, is that we have a whole concept of these auto instrumenters. So if you're in our product at all, this is very zoomed out. Basically, you have two options with instrumentation. It's either automatic or manual. If you're using LangChain or LangGraph, we have a built-in automatic instrumenter for that. So you just need to connect to your Phoenix instance with the code right here. Sorry, I'll blow this up. And then it's just one line here to automatically instrument everything you're doing with LangChain. Yeah. So we have like 15 or so of those for different platforms like that. And then to be honest with you though, like that'll track everything you're doing in LangChain. Typically people will then go in and add some manual like tweaking if they want things to appear differently, but that'll work out of the box for you. Yeah. Cool. Yeah. Is it, sorry, I missed the last part. Is it what? Are they? So the logs are not coming from the LLM itself. They're coming from either if you're using the auto instrumenter, they're coming from the package that's calling that LLM. So like the OpenAI Python package, for example, we're basically wrapping calls in that to automatically grab data. If you manually instrument, you're actually defining, okay, like this is the response I got back in my code. This is the input that I sent through. So you're defining that manually. There's nothing that we grab from the actual LLM itself. We're kind of everything around the LLM. We're not necessarily going into the LLM at all. Even for enterprise deployments, yeah. So we're not sort of measuring model weights or anything like that for generative use cases. For more of the ML and CV side of things, we do kind of get more into that actual aspect. But for the generative side, we see up to the call of the model, and then we see the response from the model. We don't see the stuff inside. Yeah. Cool. All right. Last thing for me then is that we have another event that's coming up weekly that I'm just going to really briefly plug. This is in a couple weeks at the GitHub Reactor Space. This is going to be a really fun one because it's our CEO and then a guy named Hamil Hussein, who some folks might be familiar with. He's very sort of known in the LLM eval space and has a lot of good things to share around that. So this will be a really cool event with some folks who are really truly experts in this technology. And so fun one to check out if you want to. I'll show the slides later. Yeah. We'll send them out to the Luma. And that is all I have for everyone here. I think that's all we have for the talk. So we'll stick around for a little while longer. We might have some pizza and everything left. And we'll stick around to answer any other questions that people might have. Thank you all for coming out and really appreciate everybody's questions and attendance and everything here. Thanks.